Hi everyone, myself Dr. P. Soumya, working as an assistant professor in the Department of Chemistry, Institute of Aeronautical Engineering College. In this session, I'm going to discuss about corrosion control by using surface coatings. So, in this session, I'm going to cover the topics: types of surface coatings, metallic coatings, hot tipping, galvanizing, tinning, inorganic coatings. There are cementation, metal cladding, electroplating, and electrolase plating, and finally organic coatings. So here three types of coatings are there: metallic coatings, inorganic coatings, organic coatings. So I am going to cover all these topics in this session. Here the main function of coating is to provide an effective barrier, so between metal and environment. So between metal and environment. So we have metal and atmosphere or environment. So this surface coatings function of coatings is this will provide the effective barrier between metal and environment. So these surface coatings divided into three types. So these first surface coatings divided into two types, that is non-metallic coatings and metallic coatings. So these non-metallic coatings again divided into organic and inorganic coatings. So finally we are having three types of coatings: metallic coatings, inorganic coatings and organic coatings. So the coating may be acts as sacrificial anode, or this release substance that inhibit corrosive attack on the substrate. So it may act as sacrificial anode, otherwise it may used as an inhibitor, which is used for the protection of metal. So example of these surface coatings are paints, drying oils and varnishes and synthetic clear coatings. Here first topic is metallic coatings. So in this metallic coating, the surface of base metal is coated with another metal, so that is called as coating metal. So in this, the metal to be protected, it is called as base metal. The metal to be protected is called as base metal. And the the coating which is used for this metallic coating, so that is called as coating metal. That is called as coating metal. So here, so this is base metal. So we are coating with two coating metals. So this is first coating metal, second coating metal. The metal which is to be protected is called as base metal. The metal which is used for the coating of metal, so that is called as coating metal. So these metallic coatings are broadly classified into anodic and cathodic coatings. So the anodic coating. So what is anodic coating? So the metal used for the surface coating is more anodic than the base metal which is to be protected. So in this, so the base metal, in this, the base metal should be here. The coating metal should be more anodic. The coating metal should be more anodic than the base metal. So this should be more anodic than the base metal. So for example, aluminium, the coating of aluminium, cadmium, zinc on steel surface, it is acts as anodic coatings. So the coating of aluminium, cadmium, zinc on iron or steel surface, it is an example of anodic coating. So in this, these are anodic because their electrode potentials, means the aluminium, cadmium, zinc electrode potentials are lower than that of the base metal, that is iron. So here we are coating the aluminium or cadmium or zinc on the iron metal. So these three metals are having lower electrode potential. So these three elements, these three metals having lower electrode potentials than iron. Lower electrode potential than iron. So this will act as anodic coatings to the iron. So therefore these anodic coatings protect this underlying base metal, that is iron, sacrificially. Means these anodic coatings can undergo corrosion, and these metals can protect the base metal from the corrosion. So by sacrificially, they sacrifice their life for the iron metal. So here, so this if any formation of pores or cracks occurs, if any, so here we are coating the aluminum or zinc or cadmium coating on the base metal. So this is the base metal. So here we are, for example, aluminum. So the layer which is we are coated on the iron. So if it is have pores or any cracks, so when the base metal, this is exposed to the environment. So when the formation of pores and cracks over the metallic coating, the exposes the base metal to the atmosphere, and here galvanic cell is formed. Means anode and cathode will form. Galvanic cell formed means anode and cathode will form. Here anodic coating is acts as anode and base metal can access cathode. So even it exposed to the atmosphere, so the base metal cannot undergo corrosion because it is coated with the anodic metal. It can act as cathode. So even it exposed to the atmosphere, it can act as cathode. So it is having corrosion resistance due to the anodic coating. And this metal is protected by the anodic coating. So this is about anodic coatings. Here we are taking example of coating of aluminum, cadmium, zinc on a steel or iron. So these are having lower electrode potential, so they can act as anode, and the base metal it can act as cathode. So the anodic coatings are protected this base metal from the corrosion anodically and sacrificially. Here, second one is cathodic coating. The cathodic coatings are obtained by coating more noble metal. So here we have to coat the more noble metal. So like silver, aurum, platinum and tin. Silver, aurum, platinum, tin. So these metals are called as noble metals. So for cathodic coatings, so we are using noble metals as a coating metals. Coating metals. So the cathodic coatings are obtained by coating a more noble metal that is having higher electrode potential. So like tin, silver, aurum, platinum, so than the base metal. So these are having more electrode potential, higher electrode potential than the base metal, that is iron. Here we are taking iron. So these noble metals having higher electrode potentials than the iron, so they can access cathode. The coating metal can access cathode. Coating metal access cathode, and whereas iron can access anode. So the cathodic coatings protect the base metal as they have higher corrosion resistance than the base metal due to cathodic nature. So these noble metals are having cathodic nature. So these are having higher corrosion resistance than the base metal. So due to that, so these coating metals can protect the base metal from the corrosion. So these cathodic coating protects the base metal only when the coating is uniform and free from pores. So here these cathodic coatings protects the base metal only when the coating is uniform and free from pores. So here if any formation of pores or cracks, on the coating. So this will exposes the base metal to the environment. So here also we will get anode and cathode. Anode and cathode. Galvanic cell is formed because of the exposure of base metal to the environment. So here this is base metal is, we know, the anode. So with respect to the coating metal. So this can act as cathode. So when this base metal is exposed to the environment, so this is anode. So this can undergo corrosion. This can undergo corrosion. So this cause more damage to the base metal. So when cathodic coatings have pores or cracks, so the base metal can undergo severe corrosion. The base metal can undergo severe corrosion. See, so here this causes more damage to the base metal. So whereas anodic coatings, if they have pores and cracks, no damage to the base metal takes place. But in case of cathodic coatings, so more damages takes place because of the pores and cracks which are formed on the cathodic coatings. Here next process is hot dipping. So this is the process of coating metal on the other metal. So hot dipping is the process. It is applicable to the metals having higher melting point than the coating metal. So here what is the condition? The coating metal should have, the base metal should have more melting point. Base metal melting point. So this should have higher melting point than coating metal. So this should have higher melting point than the coating metal. So it is carried out by immersing a well cleaned base metal in a bath containing molten coating metal. So in this process we are taking molten coating metal. Molten coating metal. So we are dipping the base metal in the molten coating metal and flux layer and flux layer and flux layer. So in this process, here this is process involves by immersing a well cleaned base metal in a bath containing molten coating metal and flux layer. So what is the use of flux layer which is used in the hard dipping process? Here this flux cleans surface of the base metal, and it will prevent the oxidation of the molten coating metal. So we are having molten coating metal. So this flux layer is used for the prevention of oxidation of molten coating metals. So all we know that the metals, all metals can undergo oxidation corrosion at high temperatures. At high temperatures. So to prevent the oxidation of this molten metal, so we are using flux material in hard dipping process. So this is used for the cleaning of surface of base metal as well as prevents the oxidation of molten coating metal. So here example of this hard dipping process is coating of zinc, lead, aluminium on iron and steel surfaces. So the most widely used hot dipping processes are galvanizing and tinning. Galvanizing and tinning. Galvanizing and tinning. Here first process is galvanizing. So the process of coating molten zinc on the base metal surface by hot dipping process is known as galvanization. So here we are coating molten zinc on iron. So it is the process of coating molten zinc on the base metal surface by hot dipping is known as galvanization. Here we are coating zinc on iron. Here we are coating zinc on the iron. So this process, this hot dipping process is called as galvanizing. So galvanization of iron. So we are coating zinc on the iron plate or iron sheet. So in this process of galvanization, the base metal or iron or steel, it is coated with a thin film of zinc metal. So since the zinc is higher up in the galvanic series, the zinc coating acts as anode. So this is having lower electrode potential than iron. So this is having, the zinc is having lower electrode potential than iron. So this can be acts as anodic coating. The zinc coating acts as anodic with respect to the base metal. So the base metal is acts as cathodic. So with the repeated exposure of galvanized metal to the environment, only the coated active zinc gets corroded. Thus the base metal or iron or steel, it is protected. So this zinc can prevent the iron or steel sacrificially. Here this is the process, galvanization process. Here, so first the metal which is to be coated, that base metal, that is cleaned and degreased using organic solvents. So first we have to use organic solvents and we have to wash with organic solvents to remove the grease or oil. Grease or oil impurities on the steel or iron sheet. First here we are taking iron sheet and we are cleaning with the organic solvents to remove the grease or oil impurities on the iron sheet or iron sheet or steel sheet. So here second we will, the metal is treated with dilute H2SO4. So the metal is treated with dilute H2SO4 at 60 to 90 degrees centigrade to remove the rust or scales on the iron sheet. So here first step is we are cleaning with organic solvent. Second, we are treating with the dilute H2SO4 at 60 to 90 degrees centigrade to remove the scales or rust which are formed on the iron or steel sheet. Here, so the metal is further treated with flux material. So here before going to the flux material, so this metal is washed in washing bath. So from water. So the metal is washed with water and this is dried in drying chamber. This is dried in the drying chamber. After that, this is treated with flux materials. Here we are using flux materials as a zinc chloride and ammonium chloride. So these are used as a flux materials. So after that, so these are immersed in the molten zinc. These are immersed in the molten zinc at 425 to 430 degrees centigrade. So after this process, these are moved through the these are passed through the two pair of rollers to remove the excess coating metal. So after that, so this is annealed. This is cooled in annealing chamber. This is cooled. This is cooled in annealing chamber. Annealing chamber. So then finally we got galvanized sheet. Finally we will get galvanized sheet. Here galvanized sheet. Galvanized sheet. So this is the process of galvanization. In this first we are cleaning the metal which is to be protected with organic solvent, then dilute H2SO4. After that we are washing with water. We have dried in the drying chamber. After that this is passed through the zinc chloride and ammonium chloride flux which is used for the best adhesion property of coating metal to the base metal. After that, this is immersed in the molten zinc at 425 to 430 degrees centigrade. So last we will this zinc, the excess zinc is removed from the surface of the coated metal by rolling, wiping or air blow techniques. So after final step is cooling. So there after that we will get galvanizing iron or steel sheets. Iron or steel. So this is the process of galvanization. Atmospheric corrosion in the form of roofing sheets, and wires and nails, bolts, screws, etc. So pointed it may be pointed here that zinc gets dissolved in dilute acids to form highly toxic compounds. Hence, galvanized utensils cannot be used for preparing, storing foodstuffs, especially acidic ones. So, if we use this zinc coated zinc coated or galvanized utensils for storing foods and for storing food, so it is not suitable for storage of food because it will form highly toxic compounds with the acids which are in the food. So we cannot use these zinc utensils, that is galvanized utensils, for storing foodstuffs and etc. Here tinning. Second hot dipping process is tinning process. It is a coating tin over the iron or steel articles. So this process consists of first heating of steel sheet in diluted H2SO4 acid to remove any oxide film. So here what is tinning process? Here we are coating tin on iron. So tinning process is tinning. The coating of tin over the iron or steel articles is called as tinning process. In this, we are taking mild or iron sheet. So this is first it is treated with the dilute H2SO4. Dilute H2SO4. So this process is called as pickling process. So this is used for the remove scales, rust on the iron sheet, or that is oxide film, nothing but rust. Here after this it is passed through the zinc chloride flux. After this is passed through the zinc chloride flux. So this is used for the molten tin to adhere on the metal sheet. So this flux is used for good adhesion of good adhesion of coating metal on the base metal, and it will prevents the molten oxidation of it will prevents from the oxidation of molten metal. Here we are using tin metal, so it is used to this flux is help the molten tin to adhere to the metal sheet, as well as it will prevents the oxidation from the molten tin. Here next the sheet is passes through the tank of molten tin, and finally through the series of rollers from underneath the hot tin coated surface of layer of palm oil. So after immersing into the tin metal, so this is passed through the two series of rollers, and finally it is immersed. This is passed through the oil. So this palm oil protects the hot tin coated surface against oxidation. This oil or grease, that palm oil, so this can protect the hot tin coated surface against oxidation. So the rollers removes excess of tin and produce thin film of uniform thickness on the steel sheet. So finally we will get tinned steel. So this is the tinning process. In this we are coating tin on the iron or steel sheet. So what are the uses of tinning? Tin process. This tin possesses considerable resistance against atmospheric corrosion. So moreover, because of non-toxic nature of tin, this tinning is widely used for the coating steel copper and brass sheets and used for manufacturing containers for storing foodstuffs, ghee, oils, kerosene, and packing food materials. And packing food materials. So these tinned copper sheets are employed for making food, cooking utensils, and refrigeration equipment because these are non-toxic in nature. Tin is non-toxic in nature, so that's why we are using these tinned copper sheets, which are used for the making utensils, cooking utensils, and refrigeration equipments. So first metallic coatings completed. In second one is inorganic coatings. So in this first process, cementation. So this cementation is a type of precipitation. It is a type of precipitation. It is a heterogeneous process. It is a heterogeneous process in which ions are reduced to zero valence. Means if I take copper plus 2 ions, this is an ion, so this will reduce to zero valence at solid metallic interface. So the copper ions in the solution are precipitated out of the solution on solid iron. Here we are coating copper on iron. So in this, the copper ions in solution. So here iron, this is iron. So we are taking copper solution. So these copper ions from the solution precipitated out of a solution on solid iron. So this iron oxidizes and the copper ions are reduced. So this iron oxidizes, copper ions are reduced through transfer of electrons. So the reaction is spontaneous as copper is higher on galvanic than iron. So in this reaction, so copper is coated on iron. So in this, copper is undergoing reduction and iron is undergoing oxidation. Here by this technique, we will coat the copper on the iron. Here we are taking iron sheet in the copper sulfate, copper plus 2 solution. So these copper plus 2 ions coated on the iron. So this is copper coating on iron by using cementation process. So what are the uses of cementation? So we can use this cementation process in industrial recovery of heavy metals including cadmium. So the cementation of gold by zinc in Merrill-Crowe process. So next process is metal clouding process. So in this, the surface of the base metal to be protected is sandwiched between two thin layers of coat metal. So the surface of base metal, this is sandwiched. So this is sandwiched between two thin layers of coating metal and pressed between rollers. Here, so these are two coating metals. So in this is base metal. So whereas same here base metal, here this is base metal, these two are coating metals. So here base metal is, here this base metal is sandwiched between two thin layers of coat metal and these are pressed between two rollers. So this will applicable for only plain surfaces. So these the only plain surfaces can be cladded. So this method is used for coating aluminium, chromium, nickel, duraluminum. So all corrosion resistant metals like nickel, copper, silver, iron, platinum and alloys like steel or nickel alloys can be used as cladding materials. Here, duralumin is a very light metal alloy used in aircraft industry, so which is cladded with aluminium to get AL clad, aluminium cladding material. So next process is electroplating process. Here, the electroplating is the application of electrolytic cell. It is an application of electrolytic cell, so in which electrical energy is converted into chemical energy. So in this electroplating, the thin layer of metal is deposited onto an electrical conductive surface. Here we will use electrical energy. We will use electrical energy for the plating of coating metal on the base metal. So this is the application of electrolytic cells in which thin layer of metal is deposited onto base metal and electrically conductive surface area. So the simple example of electroplating process is electroplating of copper, in which electroplating of copper on other metals, if other metal or iron. So here this the coating metal to be that can be taken as anode. So the metal to be plated is used as anode, and the electrolyte solution contains the ion of metal to be plated. So here we are coating copper plate. So here first we have to use copper plus 2 ion containing electrolyte. So in this process, the copper in the copper, it is metal to be plated. It is here acts as anode. It is taken as anode, and the electrolyte solution contains the ion of metal to be plated. So the copper goes into the solution at anode, and it is plated at the cathode. So a constant concentration of copper plus 2 is maintained in the electrolyte solution surrounding the electrodes. Here we are taking coating metal, that is metal to be plated is as anode. So that is we are taking copper anode. Here we are taking copper sulfate solution. So these copper ions, this is anode. So this can undergo oxidation and it will form copper plus 2 ions at anode. So this will move to the electrolytic solution, and these copper plus 2 ions undergo reduction at cathode, and that can be plated over the cathode. That can be plated over the cathode. So here we are using electrical energy to plate the copper plate to copper plating on others other metals. So this process is called as electroplating. So at anode, oxidation of copper is taking place. Copper anode is undergoing oxidation and forming copper plus 2 ions. So these copper plus 2 ions undergo reduction at cathode, and these are plated on the cathode. This is about electroplating. Next process is electroless plating. In this electroless plating, the noble metal is deposited on a reactive metal without the passage of electron. Here, noble metal is deposited on a reactive metal without passage of electric current. So in case of electroplating, we are using electrical current. In electroless plating, we are not using any electric current. But here, we are coating the metal. We are plating the metal, noble metal, on the reactive metal. So here, an alloy of noble metal is taken. In presence of reducing agent, the alloy undergo reduction. So here, for depositing noble metal on the reactive metal, here we are taking alloy of noble metal. In presence of reducing agent, this will undergo reduction. So alloy can undergo reduction. Alloy can undergo reduction in presence of reducing agent. So finally, the noble metal which comes from the alloy will stick to the reactive base metal. So that will stick to the reactive base metal. So this method is also called as autocatalytic coating. This method is also called as autocatalytic coating. Example, reactive metal is iron. Here, reactive metal means the base metal is iron. Base metal is iron. So here we are taking alloy, nickel chloride alloy. So reducing agent, sodium hypophosphate, NaH2PO2H2O. So here taking reducing agent, sodium hypophosphate, alloy as a nickel chloride. Here the base metal, example iron, it is immersed in hard solution of nickel chloride, and the sodium hypophosphate at 100 degrees centigrade at pH 4.5. Here nickel plus 2 ions reduced to metallic nickel. So in this we are immersing the iron metal in hot solution of nickel chloride and sodium hypophosphate. So this is having nickel, this is having nickel chloride and also reducing agent at 100 degrees centigrade pH 4.5. So we are immersing the base metal into the solution, hot solution of nickel chloride and sodium hypophosphate at 100 degrees centigrade at pH 4.5. Here nickel plus 2 ion is reduced to metallic nickel. Here nickel plus 2 can reduce to metallic nickel. So an alloy of nickel sticks to the base metal surface. This nickel is sticks to the base metal. So this is the process of electroless plating. Here we are immersing the iron in the hot solution which is having nickel chloride and reducing agent. Nickel chloride and reducing agent. So in this nickel plus 2 is converted into nickel at cathode. So we are taking reducing agent. So this is undergoing reaction with water and it is forming H3PO3 minus 2H plus and 2 electrons at anode. Here this is undergoing oxidation, this is undergoing reduction. So the net reaction is here nickel plus 2 plus H2PO2 minus H2O. It will give nickel. So this will be used for the coating of base metal. So this will coated on the base metal. So this is electroless plating of nickel. So here in electroless plating, here the plating is evenly distributed over the entire surface including external and internal corners. So this is about electroplating. So this is not uniform, this is uniform. So electroplating is uniform. Here electroless plating is not uniform. Third coating is organic coating. The coating liquid generally consists of solvent, resin and pigment. The organic coating that is consist of solvent, resin, pigment. So this will give color and so this solvent and resins have so lot of applications, lot of uses in the organic coatings. So the resin provides chemical and corrosion resistance and the pigments may also have corrosion inhibition. So the resin and also pigments, this can prevent the metals from the corrosion. So resin provides chemical and corrosion resistance and the pigments may also have corrosion inhibition functions. So examples of organic coatings are paints, lacquers, varnishes. So organic coatings are chemically inert to corrosive environment. So these are having good surface adhesion, impermeability to water, gases and salts. Organic coatings, so these paints form a protective layer over the surface of base metal to prevent corrosion. So this will form a protective layer over the surface of metal to prevent the corrosion. So these consist many constituents that paints are pigments. The main constituents of paints are first one is pigment, vehicle, thinner, dryers, fillers, plasticizers and anti-skinning agents. The main constituents of paints are pigment, vehicle, thinner, dryers, fillers and plasticizers. Final one is anti-skinning agent. First one is pigment. Pigment, it is a solid constituent that obscures the surface and provides a decorative color. So the pigment, this will provide the decorative color to the organic paint. So here the liquid binds to the pigment to the surface and protects it from the decay. So the liquid binds to the pigment and this is used this will used for the protection of metal from the decay of metal, means corrosion. Here it is usually comprises 60 to 80% of weight of the paint film. It increases life of paint film since it prevents the entry of ultraviolet rays. So because of the decorative color, it prevents the entry of ultraviolet rays to the metal. So it increases the lifespan of paint film. Examples of these pigments are lead oxide, lead chromides. So these are lead chromate and lead oxide. So these are having different colors. Vehicles, the film forming constituent of the paint. So this is vehicle is the film forming constituent of the paint. So these vehicles hold the pigment on the metal surface. So this is used for the holding the pigment on the metal surface. They give metal adhesion to the metal surface. So this is used for the metal adhesion to the metal surface. So they impact durability and toughness to the film. They isomerize, polymerize, and condense to form characteristic, tough, elastic, coherent, highly cross-linked structures macromolecular film. So examples of vehicles are mustard and sunflower oil. Here, the pigment and binder. So this is vehicle. So finally, we will get paint. So this is a film forming constituent of the paint. Thinner. Viscosity of paint, it is reduced by addition of thinners. The viscosity of paint is reduced by the addition of thinners. It is volatile solvent. Helps to adjust the consistency of the paint. It is volatile solvent and helps to adjust the consistency of the paint. Thinners, being volatile, evaporates. They remain permanently in paints, varnishes. So they improve elasticity of the film and they can use to suspend the pigments in the paints. They can suspend the pigments in the paints. Examples of thinners are turpentine, mineral spirits, xylol, kerosene. So these are used for the reducing viscosity of the organic paints. Fillers. These are inert materials. These are used to improve the properties of paints. They reduce the cost of paints. They serve to fill the voids of the film. They serve to fill the voids in the film. So these increases the random arrangement of pigment particles. This improves the durability of the film. So examples we are taking fillers, dark chalk, silica, etc. used as fillers in the organic paints. Here dryers. So dryers, the drying of oil film is accelerated and catalyzed by dryers. So these are used as a catalyst for drying process. So these are catalyzed by dryers. So here to reduce the drying time, this dryer is added. So to reduce the drying of paint, so dryer should be added. So they are oxygen carrier catalyst to improve the drying quality of oil film, and this is done by condensation, oxidation, polymerization. So examples of dryers are linoleates, borates, resinates, etc. So these can be used for the reduce the drying time of the paint. So last constituent of organic painting is plasticizer and anti-skinning agents. So they remain permanently in paints and varnishes. They improve elasticity of the film. These plasticizers, improve the elasticity of the film. So these prevent the cracking of the film. So they improve the elasticity as well as prevent the cracking of the film. These anti-skinning agents prevent the gelling and skinning of the paint film. So these will prevent the gelling and skinning of the paint film. So examples of plasticizers and anti-skinning agents are tricrysyl phosphate, triphenyl phosphate, dibutyl tartarate, etc. So these are used as a plasticizers and anti-skin agents in the organic paints. So these improves the elasticity of the film, prevent the cracking of the film. So these will prevent the gelling and skinning of the paint film. So like this we can prevent the corrosion of metals by using surface coatings. So, thank you all.
Like, share and subscribe. Hit the bell icon for more updates.